Good morning. Welcome back at the third webinar of the online D&E event. On this third day already of the event, we continue with the presentation of Logic Technology. The speaker of today is Norbert Wiechowski, based in Germany. The title of his presentation is Arttest, a customizable test environment for embedded systems. He will present in around 30 minutes everything around this subject. Please feel free to ask your questions in the public chat. We also have a colleague of Norbert, André de Koning, as moderator, and he will be able to send the questions to the speaker. So let's say good luck with the presentation, Norbert, and for the viewers, have a nice presentation.
Thank you very much for the introduction. So hello, everybody. My name is Norbert Wiechowski, and I am one of the founders of Mindmotiv. And today I will talk about Arttest. So Arttest is the name of the tool that we provide, and which is basically a customizable test environment for embedded systems. So we will start with a short poll to get some insights about you and your audience and what tools you use and which frameworks are relevant for you to do the quality assurance. It would be very interesting for us to see the results at the end of the presentation. So, coming to the first slide, automotive software is becoming more and more complex. So I think most of you have already heard about. So for the most visitors, this statement will not be groundbreaking new insight. But what we experience is that this does not only hold for the automotive industry, but more or less for all the embedded software domains, since more and more sensors have to be integrated, more optimization has to be integrated, more actuators have to be integrated, and so on. But what often falls behind by the wayside is the quality assurance, which is directly related to the software, which is becoming more and more complex. So I think it's obvious, the more complex the software becomes, the more complex becomes the quality assurance, especially in safety critical domains. And this is where currently many companies still have a big gap, as there is often no solution that meets the specific requirements of the company. Right? So especially regarding the functional testing, which is definitely one of the most complex test procedures, I think, this is a challenging task, since no algorithm is currently able to do this automatically. So when we talk about functional testing, this always means that we have to specify requirements, how the software shall behave. We have to specify test specifications, how we can test the desired functionality. Then we have to implement the test specification to meet the requirements of the target platform. Afterwards, we have to execute the test specification, and we have to evaluate the recorded results to see if the simulated results meet the expected results. And afterwards, we create a report which documents the testing process. And of course, the report has to be of a good quality so that we are able to reconstruct the results anytime. So what does this mean in practice? In practice, this kind of testing means that it involves a lot of extensive signal processing, because your test scenarios have to be translated in a way that your system under test is stimulated correctly. So you have to capture all the output values, and you have to evaluate the correctness of the generated output value. So therefore, you have to think of tolerances, sequence, different signal types, and so on. And you have to do this, especially in the automotive industry, at the model level, at the code level, at the hardware level, and at the product level. So we have to execute more or less the same functional tests in multiple steps of the development process. And this is really time consuming and also error prone for most companies, since there is currently not a tool available which does this automatically on all the levels. So, and especially in the automotive domain, where gigabytes of data are generated in a really short amount of time, typically within milliseconds, this is a really big challenge. So originally, we made our tool Arttest for automotive quality assurances, But due to recent adaptations and new research results, we were able to open our architecture of the solution and modularized many techniques. So especially the parts for signal processing were modularized and now are able to be used as a standalone version. And so by that, we are now able to support more or less arbitrary platforms, be it at the model level, the code level, the hardware level, or custom development of your own. So you specify the signals, and we generate a test implementation which is targeted to your platform. And so with Arttest, you're able to specify your tests, and we can deliver a customized version, especially for your needs and for your hardware platform. For example, we can customize Arttest so that it's only applicable for testing your embedded device with your processes. On this slide, you see two examples, what we did in the past. On the monitor, you see a screenshot of Arttest, which controls a hardware test bench. So the one on the left is a commercial test bench you may know from DSpace. It's a DSpace Scalexis system, and it's very common, especially in the automotive industry. On the right, you see a custom in-house solution that we adapted to Arttest, but both setups were done for functional testing of embedded software at the hardware level and customized according to the needs of the customer. So, and the picture you have seen in the last slide is actually also a test bench that Mindmotiv created especially for the needs of the customer, and which is based on back-off terminals. Because expensive or test benches in the automotive industry can be really expensive. You need a lot of training to use them. You need a lot of tools to use them. And typically, you can use them only for one development level, for example, for the hardware level. So, and what we did with this back-off terminals was to patch a Linux operating system, the real-time patch, so that we were able to generate a C implementation that could be executed, for example, on a NUC or also on a Raspberry Pi in real time. And via EtherCAD, the simulation of the ECU could also be done in real time. So additionally, we added full CAN support to the Raspberry Pi or the NUC, so that we could use this kind of test bench for closed-loop testing at their hardware level, and it was really easy to extend them via custom back-off terminals. So by that, Arttest was used to support testing at all levels, starting at the model level with MATLAB Simulink, up to the processor on the loop, and up to the hardware level with exactly the same test specification. So Arttest generated a fully functional test implementation for all the levels based on one single test specification. And of course, you can imagine that this makes a comparison between the results, so between the levels, between the model level and between the hardware level, for example, very easy. So rapid prototyping was very fast done, and also the error correction at the model level when the bug was found at the hardware level was also very easy. So, and another issue that I want to talk about, because we experienced it a lot in the last years, is that locally distributed teams have big troubles to work together or to share expensive resources. For example, sensitive data like models, scripts, and a lot of know-how and IP has to be sent via email to suppliers. Test benches, which are located at a dedicated site, can only be used during office hours. Tools are not available, which are required, but due to expensive license costs, not available at this specific site. And a lot of manual steps are necessary to implement continuously repeating steps. So this is a big waste of energy and resources. So what we did to meet this challenge was to provide a subset of our solutions especially the ones for signal processing and automation, as a microservice. And this has the big advantage that these microservices can be accessed directly from a browser, wherever you are. So the same holds for test benches, custom simulation environments, and so on. We wrote an adapter so that a custom test bench or a commercial test bench like the one from DSpace can be directly connected to a cloud service that we provide. So in principle, we can connect every desired resource that you have in your company to a cloud-based system. So what is the big advantage of that? The advantage is that, for example, in the context of testing, tests can be automatically scheduled from everywhere in the world just by using a browser. So the test bench can be, for example, located in Asia. You are sitting in let's say, in Netherlands or Germany, and you want to execute a test, but you have no test bench available, then you just send it to your own cloud infrastructure. The cloud infrastructure looks if there is a matching Hill test bench available, and it schedules your test directly to this test bench as soon as the test bench is free and if it matches to your test requirements. And you get the results directly back. So especially in the current times, I think this is very advantageous, because then you can also do the hardware and the loop testing straight from your home office. Because all what you need is a browser and nothing else. So no wire test bench anymore. Additionally, we increased the security of the artifacts by that, since a manual forwarding of sensitive data, all the scripts, all the requirements, and whatever you have, the models, the code, is not necessary anymore. So the cloud scheduler automatically forwards all these resources directly to the test bench, uploads them to the test bench, executes the simulation as it is specified in the test specification, gets the result back and sends them to your browser, and you can look at the results. So a copy and paste of the resources is not possible anymore. So what does this mean for hardware manufacturers? For hardware manufacturers, this means that they can easily provide a fully fledged test environment for their custom embedded devices without having to develop the test environment by themselves, which is really a lot of work, especially if you want to comply with industrial norms and standards. So all they have to do is to write a minor adapter which connects their test environment via our API to our cloud service, and then you can use all the power that we provide. So the use cases for the cloud-based technology are very manifold and strongly depend, of course, on the domain you're working in. But there are a lot of benefits for everyone, since quality assurance can be automated and optimized by that to a very high degree. As a consequence, the time to market can be dramatically reduced by increasing the software quality at the same time. So if you need a test environment to test your devices or to comply with domain-specific standards, or if you're interested how you could benefit from this cloud-based technology to integrate your embedded device, to provide a test environment for your embedded solutions, don't hesitate to contact me. On the next slide here, you see my contact details. Just send me an email if you like. So then I would like to thank you for your time. And if there are any questions, I'm happy to answer them now. Also, if you look in the chat, and you want to see how Arttest works in practice and what we can provide for you, we will provide a call to action so that you can register for everything. And we will demonstrate, especially for your needs, how Arttest can work. Okay, thank you very much.
Thank you, Norbert, for this presentation. We do have time for questions. Around 15 minutes we have time for questions, so please ask your questions. I see the first one is coming in already. The question is from Jo Schalken-Pinkster. Is there a way to test drive Arttest?
Sure. We will present, or we will send the call to action. You can register there, and then we will make a custom workshop for you, and you can test drive Arttest.
Thank you. We will wait for if some more questions will come in. I don't see any more questions. You can see the link where you can subscribe for the workshop that Logic is organizing. If you want that, you can click on the link which is directly in this presentation, in this webinar. I don't see any questions. We will share with you this presentation also the day after or tomorrow. So if you then have questions, you can still contact also Norbert or a colleague André. For now, I don't see any questions coming in anymore. So I would like to thank Norbert for this presentation. As you also comment from the visitor, Ludo, we thank you for the presentation, also from Theo. I think it was a clear communication presentation. We continue after the lunch break. We now have a lunch break of an hour. After that, we continue with 3 webinars. Webinars from HMS Network about real-time embedded communication without using stacks. After that, we have Stuart Meerlis from Picotech on behalf of C and Rood. The challenges of debugging of mixed signal designs. And last but not least, Erik Kroon from Nokia with a presentation about mobile edge computing. So you can still register for those webinars if you like and if you have the time. Thank you again, André and Norbert, for the presentation. Thank you for the visitors to follow this presentation, and we hope to see you at one of our next webinars. Have a good day.